So this is on solving rational inequalities. Solving rational inequalities. And the first one that we're going to do is x squared times x plus 4 times x minus 7 divided by x plus 2 x minus 3. And we want to find out what the x can be that would make it so this is less than or equal to 0. So can somebody remind me what this stuff on the top typically, like these factors, what do they typically represent on the graph? X-intercepts. So what do those equal? Those equal 0, right? Are we allowed to equal 0? No. Wait, look at the inequality. Yes, so we're allowed to equal 0 there. So I'm going to draw a number line for this. And I'm going to have negative 4 over here, and 7, and 0. And I just got those numbers from the factors. And I can equal negative 4 because that's an x-intercept, and I can equal 0. And I can equal 0, and I can equal 7. Those are all okay. Are we doing okay so far? All right. Because 7, the y-coordinate, so we're saying the x-coordinate would be 7, but the y-coordinate would be 0? Oh. Yeah. Okay. So then, these two on the bottom are typically what? Asymptotes or wholes, right? And in this case, they would be asymptotes if we were to graph this. And so then what I'm going to do is I'm going to add this to my number line, so negative 2 is right here. And am I allowed to equal negative 2? No, that's an asymptote, so definitely not. Am I allowed to equal 3? No. Okay. So now, inequalities have ranges of numbers, and all I have to do is check every single range and see which ones work and which ones don't work. Okay? So what we're going to do is we're going to do this on our calculator because it's easier. And you can plug it in on the normal calculator screen, but it's way easier to just graph it and plug it in there. And then we can cheat because we can look at the graph and help us make sure our answers are right. So I'm going to type this in. I hit alpha y equals so I can get that fraction up there. X squared, and then x plus 4, and x minus 7. And if you have an older calculator, you have to be really, really careful about your parentheses here. X plus 2, x minus 3. So if you have an older calculator, you're going to have to put an extra set of parentheses around the whole top and an extra set of parentheses around the whole bottom, just to make sure you graph it correctly. And usually when I do this, when I am graphing to like check my answer, I typically go through and I just make sure I got all these numbers right. Now this is pretty obvious because they set up the problem so you could easily find these numbers, but this is not normally how the problem is when you first see it. Normally your goal is to get it to look like this, so then it's easy to solve from there. So on this one, if you just want to verify that you had all the points right, I'm going to hit second trace, and I'm about to plug in x values. Alright, and the first thing I'm going to do is double check and make sure I have the right x values on my number line. So I'm going to plug in negative 4, the y value is 0, so that's the right number. Negative 2, nothing shows up for y, so I can't equal that one. Plug in 0, 0 shows up, so that's good. Plug in 3, nothing shows up, so I can't equal that one. Plug in 7, and the 0 shows up. So do you guys see how I was right about the ones that we were allowed to equal, and I was right about the ones we were not? Okay, so now I just need to pick a number that's to the left of negative 4. So what's a good number to do there? Negative 6. Okay, that would work. That's positive 26, so I'm just going to write a plus up here. That's positive. Okay? Then between negative 4 and negative 2, what's a good number in between those? Negative 3. That is negative. What's a good number between negative 2 and 0? negative 1. Okay, that's positive right there. Between 0 and 3. 2. That's 30. That's positive. Okay. Between 3 and 7. That's negative. Okay. And then after 7. 8. Perfect. Positive. Okay. So now what you might be noticing is that all the stuff to the left of negative 4 is above the x-axis, right? So those are all the positives. And then between negative 4 and negative 2 is below the x-axis. So do you see how we could kind of cheat on this? We could just look at the stuff that's above the x-axis and know that that's our answer if we're looking for greater than 0. Look at the stuff that's below. Yeah. So it's not really cheating, it's more like checking your answer, basically. So then, if we're trying to say the x values that we can have and we want them to all be less than or equal to 0, which of these intervals are we going to write down? The ones with the minuses, right? Because those are the ones where we were less. So I'm going to write down negative 4 to negative 2 and 3 to 7. And that's my interval of the x values that would work.
When you're looking for a value on the calculator, you just type a number in when you're on.
Yeah, if you do second trace value, you can type a number in, and you don't have to go back to the menu to get it again. Just start typing a new number, and it will put it in there. And you could also have looked at the table, too. Like, that would have worked as well. Okay, so the next example, we're actually going to have to do some math on this one. So this one is 5 over x minus 4 is greater than 4 over x plus 1. And the very first thing that we want to do is we want to get 0 on one side so that we can make the process look like it looked the last time. So what could I do to get 0 on one side? Minus the fraction over. Can I do that? Okay. So I'm going to put 5 and then x minus 4, and I'm subtracting this one over, so I'm going to write 4 over x plus 1. And then what do I have to do next? Common denominator. All right. Anyone know what the common denominator should be? X minus 4, x plus 1. We need each of them, right? So the first fraction needs the x plus 1. The second fraction needs the x minus 4. So I'm going to say my first fraction has x plus 1, x minus 4 as the denominator. And what do I get on top when I distribute the 5 to the x and distribute the 5 to the 1? 5x plus 5. Okay. And then my second fraction has the x plus 1 and the x minus 4. And what do I get when I distribute 4 times x and 4 times negative 4? And I have not distributed the negative yet, but if you wanted to distribute negative 4, that would absolutely be okay. So I'm going to do it this way because this is how I wrote it. So now I'm going to write it as one fraction. And I should have written bigger than 0. That's bigger than 0. And this is bigger than 0. So I have not done the negative yet, so I'm going to do that now. So if I do 5x minus 4x, what do I get? I just get x, right? And if I do 5 minus negative 16, that's positive 21. Okay. So does it match the way that our first example looked now? So now we can go ahead and do the number line like we did before. So what does the part on the top tell us? X-intercept. So we have an x-intercept at negative 21. And can I equal the x-intercept? No. Why not? Because this has to be greater than 0, right? And it's not allowed to equal 0. Okay, and then on the bottom, what do we have? Yeah, we have asymptotes, right, or holes, but this time they're asymptotes. So at negative 1 and at 4, and I'm never allowed to equal those. So these are the sections that I'm checking. And to make sure that you get this one right, this is going to be more important to check because we did more work. Do not plug this one into your calculator because you probably got those right. Go back up here and plug this one into your calculator before you simplified stuff, because if you made a mistake, this is where you're going to find it. So minus 4 over x plus 1. And we know that we're going to have an x-intercept at negative 21, so I'm going to change my window to go past negative 21. And that's because I know that my number line had to at least go that far. And so the first thing I'm going to double check is just that these three values really do make sense. So I'm going to plug in negative 21. That y value is 0, and that's okay. I'm not filling it in because I know I have to be bigger than 0. I'm going to plug in negative 1, and there's nothing there. And I'm going to plug in 4, and there's nothing there. So that means I really did find the right values, which is a good sign. And then we can plug in numbers in between our intervals just to double check which ones should be our answer. Yeah. It is not filled in because the symbol this time says we can't equal 0. So if it had said we could equal 0, then we would fill it in. But we can't this time. So I plugged in negative 24 and I got negative. I can plug in like negative 2 and I get positive. So if I'm looking at intervals that are greater than 0, it would be from negative 21 to negative 1, and from 4 forever after that, so 4 to infinity.